All right, so I'm going to do a video key for this exam. A whole bunch of instructions that we don't really need to read through. I'm going to imagine that this were my 7654321. That's my student number. So this is going to be 76. This is going to be 42. This is going to be 5. 7 is 1, and 2 is 6. And TAB is the fourth digit. And AX and BY, let's see, AX is not the fifth digit, so that's a 3. And BY is a 1. Okay, so there we go. So that's how we're going to work this. I'm probably going to have to come back and forth to this so I can remember what it is we're working at. But theta 1 is 76, theta 2 is 42. So theta 2 is 42. Theta 1 is what, 76? 76, okay, 76. Okay, and an interesting kind of problem with this one is that I didn't draw these to scale, like even remotely, which is pretty annoying. But we're going to go ahead and redraw these, and I'm going to try to draw them to scale, more or less. This won't be perfect, but it should kind of give us an idea. So we'll say that every one of these squares is 10 pounds, more or less, because, I've got a ruler here, so I can kind of work with that. Okay, so what we're looking at here is 80, so that's about, let's see, these things are about 1/4 inch, so 80 is, I guess that'll be 2 inches then, right, at 42 degrees, which is not 45, it's a little bit less than that, so we'll go about like right here. Okay, I'm gonna go 2 inches. Boom. Okay, so that's 80 pounds. Okay, and we've got this angle right here is 42 degrees. All right, and then we need the second one, which is going to be 8 pounds at 76 degrees. Whoa, 76. So that's almost 90. Not quite. Okay, but let's, let's go not 90, but something along those lines. Right, and this 8-pound force is super tiny compared to that 80-pound force. Okay, oh, no, we don't want that. Let's go ahead and erase that 0. Let's put a little pound there. Okay, now let's keep in mind what angles we know here. Okay, so I'm going to zoom in just on this one because now I don't need the other one. Okay, and let me go ahead and give you the angle that we know here. I'll use black for this. So obviously I can't draw perfectly parallel, but I can mostly get there. Okay, so let's do that. Okay, and I know that the angle that was given is right here. That's 76 degrees. Okay, so it's almost a full 90. All right, so then what's our resultant? Well, our resultant, I guess we'll do, or I'll do in like red or something. And this is kind of annoying, right? Because it's, it's whatever it is, right? Now keep in mind, one thing that we should expect here for our final answer is this is the angle we're looking for. Right, so we should expect that thing to be a little bit under 40, or a little under 42. So maybe it's 40, maybe it's 39, or it's 38. Who knows what it is exactly, but we do know that we expect it to be, pretty close to 40. Okay, so I'm gonna go ahead and redraw this line. I don't like my angle being all smooshed like that. Okay, so. All right, so let's see, what are we going to do here? Well, we want this side right here, this red side, okay, which is the resultant. I'll call it capital R, okay? And so that's the side we want. And we know that R, or R squared, the magnitude of it anyway, is equal to this, it's going to be equal to, well, let's see, A squared if A is the 80, and B squared if B is the 8, equals, let's zoom in up here. That's fine, we're going to do it like this. Okay, oh, no, not another equal sign. I always like to draw equal signs when I'm not thinking. Okay, minus, and the first time I made your key, I forgot the 2 right there, and it created the wrong answer, and I kept staring at it and beating myself up. So the problem here is that theta right there, and maybe I won't use theta, maybe I'll use like alpha or something. It's not really important. Let's use gamma, okay, because that's the angle between A and B. So in other words, we need this angle right here. Let's make this green right here. We need this angle between A and B, which is right there. And that's not so simple to get at, right? Because, you know, it's just like, well, you know, so we know A is 80. We know B is 8. So we know this is 80, and we know this is 8, okay? And that's super easy, but we need this gamma. So let's go down here, and let's think about what we know, okay? And so, well, let's see. I'm going to draw a parallel line right here. I'm going to dot it because, you know. Okay, so this is parallel. Oh, I don't want that color. This is parallel to the x-axis. Okay, and what I know about that thing, based on this 42-degree angle here, is that this is 42 degrees. Okay, and if I know that, and this is a, you know, this whole thing is a 90-degree angle, I know that this is 90 minus 42, so this is 48 degrees. Well, you know, and of course, maybe I should draw that a little bit tighter, but let's say 48 degrees. Okay, so let's erase all this nonsense. Okay, and so if that's the case, and this thing right here is 78, although I've drawn all over it with that, 76 is right here, then 76 plus 48 is my angle in green. So what's that? 110, 124, 124 degrees? 124 degrees. Okay, so that's just 76 plus 48. Okay, so that's how we get at that angle. And that was easily the most missed thing on this whole test. Okay, I would say maybe 1/4 of you got that angle correct. Okay, so I'm going to put that right here, 124 degrees inside that cosine, like that. Okay, and I've got 2 times 80 pounds plus 8 pounds. For some reason, I'm writing this in backwards. Let's not do that. Let's write R equals square root of, let's see here, 80 pounds squared plus 8 pounds squared. So the units underneath are going to be pounds squared, but then of course they'll get square rooted. So the magnitude of the resultant is 83.734 pounds. Okay, so and that should make some sense to you. Like if you look at this picture, that it should be bigger than 80, right? But only a little bit bigger than 80. And in fact, if it was bigger than 88, we would know it was wrong, because if these two vectors were stretched end on end, the largest number we could get was 88. Okay, the smallest number we could get would be 72, if this 8-pound vector were going straight against the 80. Okay, so that's the resulting. Now we need to know the angle, right? And in order to get the angle, it's going to be less than 42, right, by some amount equal to this angle right here. Okay, so I'm going to call that alpha, that angle, let's just call it beta. Okay, so we're going to do the law of sines here. And so what we're going to do is we're going to be using the things that are like across from each other. So this R, which we just solved for, 84.734 pounds, and the angle across from it, which is this 124-degree angle, okay, equals. Okay, now beta is the one that I want, so the angle across from it is this 8-pounder, so do 8 pounds over the sine of beta. Okay, so that's how we're going to use the law of sines to help us out here. Okay, and so I'm going to rearrange this, and let's see, so I'm going to leave this 8 pounds up here, I'm going to multiply that by the sine of 124 degrees, I'm going to divide that by 84.734 pounds. Okay, that'll give us something unitless. And then I'm going to invert the sign from both sides. Okay, take the arc sign, as it were. Sine, inverse sine equals beta. Okay, and if I plug that all into my calculator, I'm going to get, okay, that number of degrees. Okay, and you know, obviously, you know, a lot of significant digits here. So then if I really wanted to know this angle, you know, in red, which I guess we could call, I don't think I've used alpha, we'll call that alpha. Then alpha equals 42 degrees minus, you know, beta, 4.4892 degrees. And so alpha equals, let's just, I'll use my calculator for this because it's just going to speed things up a little bit, 511 degrees. Okay, so my ultimate answer here is that R equals, let's see, what was that number? 84.7 pounds at, now notice this angle is measured from the, I guess what you would call from the left or from the west. It depends on what you want to call it. And we'll call that 37.5 degrees, okay? 3 significant digits, and that's what you get, okay? So that's that one. Now we're going to do this again. Okay, so that's the A portion. Here's A. Let's do B. And B I'm going to do over here because why not? Okay, so I guess we'll do my components in, maybe we'll do them in red. The nice thing about this is I don't need to draw. I don't need my ruler. So we've got this, this 8-pound force. We'll call that number 1. So I'll call that force 1 equals, and I've got an I, and I've got a J. Okay, and notice that the I is going to be, looks like the I is going to be negative. The J is going to be positive. Okay, for force 2, okay, the I's will be negative. Okay, and the J's will be negative. So this one's a double negative. We had a lot of sign errors here. I don't want to accuse anybody. Very common. Okay, sign errors are, well, they hurt, right? They hurt. Okay. Let's look at F1. So F1, the triangle looks like this. Okay, you could have done a different triangle. You could have done the other triangle, but you would have had to get a different angle. So I like this triangle right here. So what we're going to do is this side right here is going to be 8 pounds times, that's the adjacent. So this is 8 pounds right here. So if you do that's cosine of theta. And this one right here, this is the opposite. So it'll be 8 pounds sine of theta. So if I go over here, well, theta being 76, let me go ahead and put that in there. We're going to put the 76 here and here. Sine, oh, well, let's do that in red. 76 degrees and 76 degrees. Okay, so again, we're going to use a calculator here. And let's see here. The x portion is 8 sine 76. Okay, and that's 7.7624. 7624. That's pounds. And though the 8 pounds cosine 76 is 1.9354. 354, and again, that's pounds. Okay, so we're going to do basically the exact same procedure down here for F2. Okay, we're going to go, okay, well, let's see, we're going this way, and then we're going this way. Okay, so in the x direction, we get, and this is 80 pounds right here, so that's the hypotenuse, so we'll do 80 pounds times the cosine, because this is the adjacent side of theta 2. Theta 2 is 42. Let's go ahead and, put numbers in. 42 degrees, like that. And then this one will be 80 pounds, and this is the opposite side, so it'll be sine of 42 degrees, like that. Okay. So again, we're just going to plug that in calculator. So the x component is 80 cosine 42, and that's 59.452 pounds. And the y direction is going to be 80 sine 42 equals 53.530. 530, excuse me. 30 pounds. Okay, and if I want to add those two, if I want to say, well, what is the resultant? Well, I'm going to add them together. Okay, and I'll say the resultant equals, well, that's what we have calculators for, right? 7.7624 plus 59.452. And I get, let's see here, 67.214 in the I, and that's a negative. It looks like we're going to have a negative here as well. 53.530 minus 1.9354 equals. So this will be negative 51.595. 595. Okay, and these all have units of pounds. Okay, so now the last thing we need to do is we need to figure out the magnitude of that resultant. And we'll do that by going, well, 67.214 squared. Those are pounds squared plus 51.595 pounds squared. And of course, I don't worry about the negative sign because this is all, everything's getting squared. Okay, so we get 85.131 pounds, which I'm assuming is what we got over here. Oh, no, there's a slight error somewhere. That's interesting. Did I copy something down wrong? Aha, I think I found it. Okay. Yeah, I plugged these things into the calculator wrong. Okay, so if you plug these into the calculator correctly, we get 84.733 pounds, which I think should be what we got over here. 84.734, 84.733. Okay, hence 5 significant digits. Okay, so that checks out. Okay, so then let's get to go ahead and get my angle. The nice thing about doing it this way is we don't have to worry too much about any weird things. So it's always the same way. So basically we've got a triangle and it looks like this. Let's see. So if I look at these numbers right here, right, I've got R, so I've got negative 67 going this way, 67.214 going this way, pounds. And I got something going down this way of 51.595 pounds. Okay, so the nice thing about this is, ignoring my sloppy, my thing moved on me, but I can say that theta equals the inverse tangent. So tangent is the opposite of 51.595 pounds over the adjacent, which is this one, 67.214 pounds. Okay, and so this theta is going to be, and I guess, I shouldn't call it theta, I should call it alpha, which is what I used on the other side. So let's call that alpha, alpha, alpha. Let me go ahead and erase it right here so we can be a little bit more professional here. Alpha. And so if we do that, we'll get to, let's see here, inverse tan of 51.595 divided by 67.214. And we get, 37.511 degrees. So our final answer, if we combine all those, is that the resultant equals 84.7 pounds at, now again, we have to remember which it's measured from, the negative x direction of 37.5 degrees, like that. Okay, and my guess is if we go over here, okay, these two are identical. Okay, so if you keep 5 significant digits, we're always going to, there's always the possibility you're going to get an error on that last digit. Like right here, we got a 3, right here we had a 4. But if somebody were grading you to 3 significant digits, you're not going to have a problem, right? And in this case, with this tangent, 5 was more than we needed, because we got exactly identical all the way to the last significant digit. So that's why we keep as many as we do. Okay, anyway, that's the first problem. Okay, 2 major problems I saw when solving this were struggling to get this angle right here, which we came out to 124 degrees. Okay, so make sure that you can figure that out. And then one of the other big errors was this little angle symbol, right? You need to basically say, hey, look, I'm coming from the negative x direction. I go 35 degrees in this angle, in this direction, and I get this, and that's where it is. Okay, there shouldn't be an arrowhead here. There should be one here, and there shouldn't be one here. Okay, no arrowhead there. Okay. Anyway, so those are kind of the 2 major problems I saw with this one. Okay, let's go to the next one. Okay. All right. So I'll tell you right now, the major problem here is mixing up x, y, and z. And I think that's because some of you guys try to do this formulaically. Like there's a formula for getting theta x, there's a formula for getting theta y and theta z. But we can do this by thinking. Okay, so what we're looking at is cable AC has a tension of, well, let's see, what was that number? 516 pounds. Okay, sure enough, 516 pounds. Okay, determine the components of this force acting on the pole in the x, y, and z direction. Some of you guys got the directions exactly wrong, and it's because I want the components of this force acting on the pole. So that means I want the force coming from A going to C, because this is cable AC. So it's going in this direction. Okay, so my expectation should be that X is positive, Let's see, y, well, it's going, so here's my y-axis, that's up. So this is going down, so it'd be negative y. And then the z direction, well, here's my positive z. Here's my negative z. So this is going to be a negative z. Okay, and so, just something to think about. This was easily the most common, this was a common miss, with the signs. But the other common miss here was just like taking sines and cosines with things that, are not what we're looking for or something. It was like you were doing a formula instead of thinking here. It's normal, so, I'm not giving you a hard time here. So first thing I want to do is I want to take this thing and I want to get, so here's my y component is going like this, straight down. Let me zoom in here. So my y component is going straight down this pole, okay? And then the other part of that component is, let's do it in, let's say black, is going from here out to there, right? And that's actually the wrong angle. Because what it's doing is it's actually going straight over this line right here. Come on, you can give me black, So it's going straight over this line right here. So I want to draw it kind of like that. Okay, and this is a right angle. Okay, so if that is a right angle, then that means we can use some trig here. And so whatever TAC is, in this case it's 516 pounds, okay, I can multiply, to get this side, which is, I'm going to do in blue because this is one of my final answers, I can get, let's leave it as TAC. We'll do TAC. So let's go back to black and let's erase this sucker. Let's go here, this will be TAC. And so this one, if we just do the trig, so this is TAC and this is my angle here, which, well, we can do it two ways. We can either do this using this angle, which is 30 degrees, okay, because this is 60 and this is a 30, 60, 90. Okay, or I can do it with the 60 if I wanted to. I think in the written key I used the 60, but it doesn't matter. So I can do TAC, and this is the adjacent. So this will be cosine of 30, like that. Okay, and then this other side right here, this is going to be TAC, because this is the opposite side, so it'll be sine of 30 degrees. Okay? Now what's cool here is that this one right here, this is TAC, AC in the y direction. Okay, this is the magnitude. Right, now we have to put a sign on it, but this is one part of our answer right here. Okay, now obviously we have to put in the 516 or whatever, but that's the idea. Okay, now this black force, right? So I'm gonna imagine that it's down here now. Okay, so let's imagine it's right here. Okay, so now we're gonna go down there and we're gonna do the trig for that. Okay, because we want to know, now here we're gonna get two blue forces, because the blue ones are the ones that we're looking for. So here's this force right here, that's in the Z direction. So that's TACZ equals, and then we've got this one right here, which is TAC in the X. Okay, now we've got a 30-degree angle right here, or excuse me, a 20-degree angle. Okay, so let's zoom all the way in and let's go ahead and solve for that. Okay, we know that the hypotenuse is TAC sine 30. So each of these are going to be a function of that. So TACX is TAC sine 30. That's the hypotenuse. TAC, this is also TAC sine 30. That's the hypotenuse. And then we're going to multiply those by the appropriate trig function. So now we've got this 20-degree angle. So we're going to get the x direction, that's the adjacent side. So this will be cosine of 20. And for the z side, by the way, I say z because z is kind of hard to hear sometimes. But that z side is going to be the opposite. So this will be sine of 20 degrees. Okay, so those are your answers right there. Basically, is that our final answer is going to be TAC. Okay, equals. Let's see, in the x direction, we've got this business right here. We needed sine, which we decided was positive. So positive, let's see, TAC 516 pounds. Okay, sine 30, cosine 20. Sine 30, cosine 20. Okay, that's in the I. Okay, the J, or the, is negative 516 pounds. And now I'm looking right here. Cosine of 30 degrees, and that'll give me J. And then in the Z direction, which is right here, that looks like that's going to be negative minus 516 pounds times sine of 30, sine of 20 degrees. Okay, and that's the K. Okay, so TAC equals, okay, so this is just going to be a calculator. I'll go ahead and pause while I plug it in. Okay, and space is getting a little bit tight here, so we'll do 88.241 pounds. Okay, and so because I just asked for the components here, you could say, well, TAC equals, and let's go ahead and let's like make it all pretty, like 447. Oh no, we don't want that. No. In my quest to be pretty, I screwed up. Okay, minus 88.2 pounds. Oh, not pounds. Dadgummit. Okay. K. And of course, that has units of pounds. Okay, and that's how we would solve this. If you wanted to test this, if you're like, I have time, I want to check to see if my work is reasonable, you can try squaring all three of these and taking the square root, and you should end up with 516. Of course, it doesn't mean that you did it exactly right, because if you like put the sine where the cosine should be here, it'll still work out that way. But it should work. So let's go ahead and do it real quick. I'm not even going to use these numbers, because this is just going to be like, I don't have a lot of time. I'm just like working my test, and I just want to check this real quick. So if I do these numbers, it's going to be a bit of an error because there's more rounding here. But for a quick test, I think that this should be. So what we're saying is, does this equal that? Okay, or I guess I have to put a question mark there. And so if we plug that into our calculator just to check here, so 242 squared plus 447 squared plus 88.2 squared equals. Now if I take that thing and I raise that to the half power, I get 515.9. Okay, so that's pretty good. Okay, so we can feel pretty good about that. So I can basically say yes, TAC, this equals that. Obviously, if I'd put out more significant digits, this would have been 516, but 515.9 for a check, that's pretty good. So then you can go and like box this off and feel pretty good when you go home from taking that test. Okay, if you had time enough to do that. Okay, again, you wouldn't even necessarily have to write this down. You could just plug it into your calculator and just something to make sure that you're doing it right. Okay, so that's that. This one, determine the components. Okay, I'm pretty sure this was 4. Okay. All right, so we want to know the components of the force exerted on this plate at B. Okay, so here's B. And we've got a force, and it's going this way from B, and it's 4 kilonewtons. Okay? And so what we want to do is, what we're trying to do here is we just wanted to break that down into components. Okay? Now I want to note the directions here, okay, in the x direction, negative. So we're going to end up with a negative x. In the y direction, where's y? Y is vertical up. So that force is definitely going up. So this is a positive y. And in the z direction, that's this direction, it's definitely going in that direction. So positive z. Okay? And so those are the signs that we're going to get. Okay? Now in the meantime, a lot of you guys like to do subtractions of from and to, and that's totally fine. So let's go ahead and do that. We're going to get our unit vector in the AB direction. So I believe they call that the lambda AB unit vector. So what that's going to mean is that we need to know the magnitude of AB. Let's go ahead and get that first. The magnitude of AB. Okay, so that means let's see. So in the x direction, we went from this point all the way back to there. Okay, so the magnitude we went. What just happened? Oh, it undid what I did. Okay, so you guys can't see that. Okay, so it went from B to 0 in the x direction. Okay, so what did it went? It went negative 900 in the x. So negative 900 millimeters in the x. Okay, what about in the y? And the y, it turned and it went up. Okay, so it went up 600 millimeters plus 600 millimeters. And the y. And then in the j direction, or excuse me, the z direction, the z direction, it went that way. Okay, and so it went 360 millimeters plus. Is that plus? Yes, that's plus. 360 millimeters. We'll go ahead and square that. We'll take the square root of all of that. Okay, and let's give ourselves a little bit more space, which means we're going to have to erase this before we do the next problem, but that's okay. So we plug that into a calculator. 900 squared plus 600 squared plus 360 squared. Take that whole thing to the half power, and we get 1140. 1140 millimeters. All right, so lambda AB then. Well, what's nice is once we've done this, just right underneath it, we can go, oh, well, it's negative 900 millimeters in the x direction divided by the magnitude, 1140 millimeters. So notice it doesn't matter what unit we use as long as they cancel. I. Okay, plus 600 millimeters over 1140 millimeters. Okay, J. Plus 360 millimeters divided by 1140 millimeters. Again, we just want these things to cancel. Okay. Okay, so that our unit vector looks like, well, we just have to do some calculator. I'm going to pause it. And then we got a K right here. Okay, so that's what it looks like. Okay, again, if we wanted to test this, I could square all three of these quantities, 0.78, 9, 0.526, and 0.315. I could square them, add them, and take the square root. And in this case, because it's a unit vector, I should get 1. Okay, so it's a way to check your work. Okay, so now I want to know the 4 kilonewton, which of course is going to be the force A or BA or AB. I always like to start with the lower letter, although I guess some people will do it as BA, meaning force BA is from B to A, but force AB is the opposite, right? So I don't care about that. So we're going to say this equals, and basically what I'm going to do is it's going to be equal to AB, okay, the magnitude of AB, which is 4 kilonewtons, times the unit vector in the direction we're talking about, okay? So basically I'm going to take this 4 kilonewtons, I'm going to multiply it by all those things up there, okay? So let's go ahead and plug in chug, baby. Okay, so we're going to take that 0.78 and multiply times 4, and I'm going to get negative 3.1579. Okay, that's kilonewtons. We're just going to put them all at the end. Okay, plus, and then I'm going to go back to that 0.56 number, multiply that times 4. I'm going to get 2.1053 in the J. And then I'm going to go back to that 3.15 number, not 0.315. Interesting that these two should be off by exactly a factor of 10. Yeah, why is that? Because this one, because this is a factor of 2.5 to go there, and then we multiplied by another 4. Okay, right, okay, the 4 kilonewtons. Okay, anyway, take that that 0.315 multiplied by 4, and we get 1.2632 in the K, and these are all kilonewtons. And again, I could square all three of those quantities and make sure that they add up to 4. Square them all, take the square root. Square them all, add them, take the square root, and make sure it goes up to 4. And so AB then equals negative 3.16 I plus 2.11 in the J plus 1.26 in the K. Okay, and we'll do kilonewtons. And just real quick on the side, I'm going to square those and see if it gives me what we want. Okay, before we call this done, so 3.16 squared plus 2.11 squared plus 1.26 squared equals, and we'll raise that to the 0.5, and we get 4.00. Okay, so yeah, so it's just something you can do real quick before you box this. Okay, what did that take me? 15 seconds. Okay, so it's really not a bad habit to get at, it's a good habit to get started. All right, so that's it. So then the last one here, A equals, and a lot of people missed the units on this one because there was a typo right here. And I wouldn't have taken off, except somebody did raise their hand during the test and say, you know, what's the units there? So unfortunately, you got to listen to that. It only cost you a point, but it still kind of still sucks. You know, we don't like to lose any points, obviously. So A equals AXI plus 10 in the J minus 1 in the K, newtons. And B equals 5 in the I minus whatever that is in the J, and plus 15 in the K. Okay, so now we need to go get AX and BY, which are somewhere over here. Where are they? Oh, all the way over here. 3 and 1. Okay, so we go back all the way over here. Oh, man. Okay, here we go. 3 and 1. Okay. So if we add those, we get 8 in the X direction, 9 in the Y direction, and 14 K direction. Oh, that's nice. When they're all positive, you know, that's pretty cool. And then that's got a units of newtons. And it asks for the magnitude. So the magnitude of C is the square root of 8 squared plus 9 squared plus 14 squared. Okay, and I forgot my units in there, so we'll just put a newtons right there. And we'll say C equals, let's see here, 8 squared plus 9 squared plus 14 squared equals 341. So square root of 341. Some of you left it like that. Unfortunately, in engineering, we never leave it like that. I would agree that that's a better answer. But inside the engineering profession, engineers are weak with non-decimal numbers. So you're just going to have to get used to using that if you're not comfortable with it. Okay, it's a little annoying. Okay, so this is 18.5 newtons. Okay, the biggest problem here is that a lot of people stopped here and did not go and get the magnitude. You know, and that's just, I mean, I don't know what to say about it. Just, you know, you got to get the magnitude. Pay attention to what the question's asking. Okay, so that's the whole thing. That's the whole test. Almost 38 minutes. Again, I hope you did well. If not, hopefully this helped you. If not, well, one way or the other, I'm here for you. So come talk to me if you didn't find this helpful. Oh, student number here. If this were my student number, 7654321. Okay. Anyway, take it easy. Have a good time, and you know, take care of yourselves. Remember, you're more important than this class, than your degree. You know, your mental health is more important, straight off the board. So if I can help you, come chat with me. I will try. Okay, take it easy, guys. Bye.